Next, he inserts the lock into the bottom of a coin can that's made of plastic. He closes it and then puts it on what's called a sonic welding machine. It emits high-frequency sound vibrations that actually melt the rigid plastic, welding the top and bottom pieces together. Now these coins will be really tough to get out without that key. Next, he brushes a second lock system with a lubricant and adds a hard steel shield that will resist attempts to drill into it. This lock goes onto an iron door which will be part of the vault that contains the coin can. He brushes the lock assembly with another lubricant to make the locking operation smoother. Then he installs a rubber gasket along the frame for the meter dome window. This gasket seals the dome and protects the electronics from harsh weather. He places a tough plastic window on the gasket and tops it with a zinc strap. He screws all the pieces together. Then he places the iron case that will hold all the mechanics on top of the vault containing the coin can. He attaches the windowed cap and strap assembly with hinges. And there's a third lock to help protect the electrical components of the parking meter. After a check for fit and function, he installs the actual mechanics. This means it's all systems go. The parking meter is ready for the street. Later, the coins can be collected without even opening the plastic coin can. This special receptacle activates the lock at the bottom of the can. Once turned, the coins deposited into the parking meter drop into the receptacle. If you need to section off part of a room, there are many types of room dividers that can do the job. Accordion doors routinely divide meeting rooms. Sliding walls made up of multiple panels can easily split a large reception hall in half, or partition an office in no time at all. This particular company makes two types of room dividers: sliding panels called operable walls and accordion doors. Both have built-in soundproofing. The folding mechanism at the core of an accordion door is called a pantograph. It's made of flat steel bars riveted together in a crisscross configuration. A worker tightens the rivets just enough to hold the bars in position without impeding their movement. Then he inserts pins along the top and bottom, securing them with steel retaining rings. The pantograph is custom built to expand to the precise width of the door they're making. The pins attach to the covers that will later sandwich the pantograph, forming the accordion door's surface. To make those covers, they first make slats. This automated machine hot glues a band of cardboard onto a band of steel. Then a series of rollers progressively folds the sides upward, forming a steel edge around the cardboard. Finally, the machine cuts the continuous band into slats, whose length is the height of the accordion door they're making. Now workers pair up the slats, connecting them with cardboard strips. They feed each pair into a glue machine. The slats come out adhered to a soft and flexible type of paper that's tear-proof. Next, workers connect 6 pairs of slats to form a panel. Then they glue on the decorative surface, in this case, commercial quality vinyl. To block sound from passing through the space above and below the accordion door, a worker glues a felt and vinyl strip to the top and bottom of each panel. After lining the inside of each panel with acoustic wool, a soundproofing material, the worker gathers the number of panels required for the door's width. He attaches them using industrial-strength steel staples. Then he slips U-shaped steel channels onto what will be the door's inside folds. Using an air-powered machine called a serter, he presses the channels tightly in place. Now he installs the pantographs. The height of the door determines how many. Using steel retaining rings, he locks the pantograph pins into holes on the channels. The second cover goes on the same way. After this, workers apply a metal trim to finish off the front and back ends. They also install a handle for opening and closing the door. The door hangs by wheels attached to the top pantograph. Operable walls are made up of several sliding panels. For each one, workers build an aluminum frame, then install a soundproofing mechanism, a crank-activated aluminum seal that juts out to fill the gap above and below the panel. To make the front and back faces of each panel, workers begin with a sheet of gypsum board. To one side of it, they glue a steel sheet that's at least 1 millimeter thick. This provides soundproofing. To the other side, they glue a decorative surface, in this case laminate, a thinner version of the material used for countertops. A machine called a pinch roll applies pressure to ensure the laminate adheres well. Workers slide the face into the frame, fill the middle with acoustical wool for soundproofing, then slide in a second facing. They close up the bottom, then test the retractable soundproofing seal. The last step is to install the wheels that run along a ceiling rail. An operable wall can have one or many types of faces, from fabric, mirror, or galvanized steel to blackboard, marker board, or even cork bulletin board. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.